By now, I'm pretty sure that you've noticed that finding derivative by applying its definition is cumbersome, time-consuming, and inefficient. This is why we need to find some formulas for the derivative. So let's start with an example. I want to figure out a formula for the derivative of square root of x. I'll apply the definition of derivative f prime x equals limit f of x plus h minus f of x over h as h approaches 0. So we substitute that root x over h as h approaches 0. How do we do this limit? I'm pretty sure that you've learned this one before. You need to multiply by the conjugate, and once you multiply by the conjugate, radical disappears. Once you multiply, you need to divide as well to keep it balanced. So by applying the difference of squares, so we'll get x plus h minus x over h bracket x plus h plus square root of x. X and x cancel each other out, also h and h, and what remains is 1 over square root of x plus h plus root x as h approaches 0. So which becomes 1 over root x plus root x, which becomes 1 over 2 square root of x. Yeah, and we are done. So we found a formula for the derivative of square root of x. Therefore, if, for example, a question asks you to find the derivative of square root of x at x equals, for example, 9, all you need to do is using this formula that we just learned. So f prime x is 1 over 2 root x, and then replace x with 9, which becomes 1 over 2 times 3, which is 1 over 6. So if you keep using this formula for different functions, you can make a table. I can share you some formulas. So here is function, and here is the derivative. If your function is constant, its derivative is 0. If your function is x to the power of n, nx n minus 1 would be the derivative. Root x we just found a formula for. 1 over x is negative 1 over x squared. Sine x is cos x. Cos x is negative sine x. Tan x is secant squared x. We can keep going. Cotangent x is negative cosecant squared x. Ex is itself. Ln x is 1 over x. A to the power of x equals a to the power of x ln a, and log x to the base of a is 1 over x ln a. So this is a brief formula of table of formulas for the derivative of popular functions. We have some more. but for now I'd rather to terminate this table here.